Hello there, this is Ms. Nakayama, and today's lesson is 10.6, Counting Principles, Permutations, and Combinations. So, in this video, we are going to cover using the fundamental counting principle. We're going to use the combinations and permutations formula. Sorry, my pen's not working. Fundamental counting principle, combinations and permutations, and then we're going to make sure we can distinguish between permutations and combinations. So, first off, the fundamental counting principle says the number of ways in which a series of successive events can occur is found by multiplying the number of ways in which each one can occur. So to give you that a quick example of that, if you have 5 pairs of pants in your closet and you have 8 different shirts, then you can make 40 different outfits because 5 times 8 is 40. 5 pairs of pants, 8 shirts. How many different outfits can I make? 40. That's the kind of thing. But it's not limited to 2 events. It's a series of successive, so however many events you have, you figure out how many choices you have to make and you multiply those numbers. So here we have example 1. A pizza can be ordered with 3 choices of size, small, medium, or large, 4 choices of a crust, thin, thick, crispy, or regular, and 6 choices of toppings, ground beef, sausage, pepperoni, bacon, mushrooms, or onions. How many different one-topping pizzas can be ordered? So how many choices do I have to make? Well, I'm going to make 3 choices, so I'm going to put 3 blanks. The first choice I have is the size of my pizza, and then I have what kind of crust I want, and then what topping I want. Now, what are my choices? How many choices of size do I have? I have 3 choices of sizes. I have 4 different crusts to choose from and 6 different toppings. So how many different pizzas? I'm going to multiply those numbers, and that's going to give me 72 different pizzas. Okay. Now, a special application of the fundamental counting principle is something called a permutation. And it is an arrangement when no item is used more than once, but most importantly, it's when the order of the arrangement makes a difference. Okay? And if you were talking about a permutation, here is our formula. N factorial over n minus r factorial. And yes, you have a button on your calculator. If you can't find it, let me know. I'm going to work it out by hand just to make sure you know how to do it in case you can't find that button. But you should come see me if you can't find it. Permutations, order makes a difference. If you're lining up a bunch of people, you're thinking about people finishing a race. If you're putting books on a shelf, ordering things in your closet, those different things are examples of permutations. So, how many ways can 6 books be lined up on a shelf? Well, that's a permutation because it's a different way to line them up according to the order. So it is a permutation. I have 6 books to choose from, and I'm going to line up all 6 books. So that's going to be 6 factorial over 6 minus 6 factorial, which is 6 factorial over 0 factorial, which we know is 1. And 6 factorial is 720 ways. All right, so we had permutations. Now we have combinations. And combinations, we kind of talked about this already with our binomial coefficients. That's an example of a combination. We are selecting items from the same group. We're not using any more of them or any one more than once. And this time the order makes no difference. So our formula that we had before, but let's make sure we can tell the difference between them. This is example 3. Okay. For each of the following problems, explain if the problem is one involving permutations or combinations. How many ways can you select 6 free DVDs from a list of 200? Now, if I'm choosing 6 free DVDs, does the order that I choose them matter? And I hope you said the answer was no, since the order doesn't matter. These are combinations. In a race in which there are 50 runners and no ties, how many ways can the first 3 finishers come in? So we have a first, second, and third, but does that change the possibility or the ways that it happens if the order that those people come in? And it absolutely does. So this is an example of permutations. Okay. Now, combinations, I kind of already gave this to you in the previous lesson. It is written NCR, and it is the n factorial over n minus r factorial. So that's your permutation formula, and then you just divide by the repeats. So look at this one. Example 4, from a group of 10 physicians, how many ways can 4 people be selected to attend a conference on acupuncture? Okay, the order that we choose those 4 is not going to change which 4 are going to the conference. So this is an example of combinations. How many do I have total? 10. How many am I going to choose? 4. Y'all, the bigger number always goes first in both of these formulas, okay? So that's 10 factorial over 4 factorial 10 minus 4 factorial, which is 10 factorial over 4 factorial 6 factorial. Remember, 4 and 6 got to add up to that top number. And so when I write that out, that gives me 109876 factorial over 43216 factorial. And so the reason I do that, again, 6 factorial, and you can then simplify it or use your calculator, and that's going to give you an answer of 210 ways. All right, that is all we have. I thought there was another example. Hope y'all enjoyed that. Please don't hesitate to email me or ask me any questions. Thank you so much. Y'all have a great day.